Since we are partnering, we are doing a partnership with NEO, and some of the international community has been asking what is Elastos, what we're doing, and what's our relationship with NEO. So here it is. Actually, my background is not really in the blockchain, but I've been doing operating systems and internet-related stuff for more than 30 years. It turned out I would be the most senior guy doing operating systems in China. Okay. Actually, this latest round of push for Elastos started 5 years ago. Actually, the name of Elastos, I named it in 2002. And when I have the first drive of Elastos, we did a smartphone from scratch, including kernel, bootloader, everything, and MMI and the batteries and stuff. But turned out we ran out of luck, because when we finished the phone by the end of 2006, there are two operating systems come out. One is Android, the other one is iPhone. So it turned out we went under. And 5 years ago, I started the second drive, which is doing the industrial IoT. So when I started this project, end of 2012, we have two things in mind. One is, IoT has been around for so long, but my perspective is very much different from everyone else, because when I start this project, I have only one thing in mind, which is prohibiting, again, I emphasize, prohibiting any IoT device to go onto the internet. So no more internet access for any IoT devices, so then we can guarantee a secure, a safer smart home. Then the holy grail question would be, how can I access my video camera on a mobile phone, right? Because I want to do it remotely over the internet. If the IoT devices cannot get onto the internet, how can my phone access my video camera? Then the problem is, how can we turn the video camera into a web service on the smart router, and so then my phone can do video on demand instead of the video pushing to my phone? Can I use the phone to subscribe to the service? And there's one key question, technology problem, is that how can we guarantee if the internet, if the IoT devices cannot send IP packages, right? No more sockets for IoT devices, then I have to generate all the network traffic through a network operating system from a phone to the smart router. All the traffics are generated by the operating system, right? Okay. So that was actually the goal of 5 years ago. Of course, we had another picture, and this scenario, actually, I gave a talk by 2002. Right? When I started this operating system called Elastos 2002, we wanted to do only one thing at that time, which is doing the decentralized. Basically, again, as I said, all the traffics are managed. And so the managed terminology come back to something called a managed C, managed C#. So that's actually how I get to know NEO, why we are related, because we want everything to be managed. Managed meaning the applications cannot directly access the internet, right? So only one platform so far on the market doing managed C. So everybody can do like a JavaScript and Java being managed because they are managed by virtual machines. Yet there's only one CLR virtual machine can do native C code. And if you're looking at EOS, there's a project. I didn't really look into too much, but on the other hand, when you see EOS, it's saying there's going to be C++ embedded in the WebAssembly. So what I'm saying is that If you're doing JavaScript or Java, then you cannot do 100% of the applications unless you can support C programming language, which can guarantee you running 100% of the apps. Of course, when we start a project this year, so this is the kind of the third push for Elastos. And what we're saying is, Neil has been saying smart economy. To me, a smart economy equivalent to, can we sell a digital ebook, secondhand ebook, peer-to-peer, and which is a very simple scenario. When we go on buying a paper book on Amazon, I can resell it because that book is a property of mine, and after I'm reading it, I could sell it for half a price or can give it for free to someone. Yet, if I buy an ebook on Amazon, I cannot resell it for half a price. And there's really a difference between the cyber world and the material world. And to us, can we do it in the cyber world 100%? So that's the question. Can we sell a digital property peer-to-peer to someone else, right? So then we basically, given the blockchain can create the scarcity of digital contents, then we have to remember that not only we have to count down, who's the owner of the book or ebook, but we have to run it. For an ebook, you have to execute the ebook. When you execute it, is there a possibility being hacked? The information got leaked. There's a piracy issue. There's a DDoS issue. How do we guarantee or at least make it much harder to write a virus to do piracy, right? There we need a C++ virtual machine. So this is going back to a little bit of a history of computer science, because when I see blockchain, there are people, I don't want to go into too much detail, but the blockchain society has been abusing the term called a Turing equivalent. Turing equivalent saying, if you have a CPU, it's actually Turing equivalent, but the CPUs are not born equal. In this picture, the peripherals, like the graphics cards, the sound cards, the video cameras, whatnot, they are CPU, they are Turing equivalent, yet they are peripherals. They cannot go onto the internet. And I have to emphasize, when you say Turing equivalent, doesn't mean you can run apps, and which is really the fundamental of computer science. I mean, when we do this, so you see on the other side, all the terminals, now they have so-called, used to be dummy terminals. Now they are called smart terminals. Smart terminals are the terminals with the CPUs inside. The peripherals, when I do computer science, when I went to college, right, there are TTYs and core dumps and paper tapes. We don't really have a CPU in peripherals. So they're really dummy peripherals. But nowadays, a CPU costs you what, $1? So all the peripherals are smart. But yet why we were putting it as peripherals, as I mentioned at the beginning of the talk, for a smart home, all the IoT devices are actually peripherals. If we disallow them to go on the internet, we would have a safer home. Otherwise, when you have a camera in your bedroom, do you know what kind of picture got leaked out? And some young people say, I don't care, I don't give a damn. But on the other hand, when you have high-speed rail, when you have a state grid, when you have a nuclear plant, all the sensors, they really, really have to make sure they cannot go onto the internet. So they are peripherals. And of course, there's a cloud drive. I mean, this is the new paradigm for smart economy, for computing. So basically, when you see this, we're treating the internet as the internal bus. 20, 30 years ago, when there's a TCPIP, when there's a socket, right? And at that time, TCPIP was developed after Unix was released. The University of Berkeley implemented the first TCPIP protocol. And it turned out at that time I was at the University of Illinois. We did the first version of PC Telnet. So we implemented the first TCPIP on the PC. At that time, see, the operating system was already Linux, not Linux, Unix. Linux is a kind of like, I mean, copycat of Unix, right? So TCPIP was born after Unix. So TCPIP was implemented as an application of an operating system. If we put it, reverse the order, we put the internet as the infrastructure of virtual machines. Then we hide the sockets from applications. That's the model we're proposing. Next slide. Here's the, my understanding of a blockchain. Blockchain consists of like 6,000 nodes or 8,000 nodes for a Bitcoin network. There are 8,000 nodes, yet they form a single computer with some special properties, which is not controlled by any individual of the nodes. Still, they are just one computer, right? For any blockchain, you can think of them as a single computer, even though they are connected through the internet. So really, that's a conceptual issue. So this is the paradigm we're adapting. First of all, on this P2P network we're building, we have the public chain issuing IDs. As I said, 5 years ago, we did a smart home P2P network. Now it's in beta stage now, it's open sourced. The reason why we're doing it is because at that time, we couldn't find any open sourced P2P network for smart homes or for industrial IoT. So we have to build one and open source that. Currently, it's in beta stage and it's open sourced. When we did it for industrial IoT, the enterprise issuing the IDs for all the gadgets and sensors and users. Now, given the blockchain, we can have the public blockchain to issue IDs in a decentralized way, which is not controlled by any enterprise or individual. Yet, on top of this P2P network, a network meaning a network of computers. So it's multiple computers, including the conventional computers and the blockchain computers. For example, we'll have normal websites built on top of our P2P network. We call it macro websites. The macro websites are actually based on in the smart home routers, right? And so we can use a smart home router to be a very macro service and provide your photos to your family members. So that's the goal. We started 5 years ago, and we have the personal cloud. We have the surveillance camera. We have some peer-to-peer services running in the beta stage, but currently we're regrouping it and open source that one as the new Elastos project. And as you can see, the first thing we do with Neo is that the public chain, actually we're doing co-development and helping us to do the merge mining with Bitmain of the Bitcoin network. So this ID was based on Bitcoin network. And given we expect to go online by December 1st, at that time we hope to have about 50% of the POW computation power of the Bitcoin instantly because of the partnership, right, with the Neo, with the Han Laoshi and Wu Jihan. The second project that we're collaborating is that on top, if you see those green circles and another Bitcoin machine, the green circles are actually virtual machines. And the virtual machines are C++ virtual machines. When we do virtual machines, you can say, well, Java virtual machine, JavaScript virtual machine, but can you do a C++ virtual machine? So that's the green circles. And on top of that, as I said, we'll have like microservices for home and normal services with IP addresses like normal websites. But we can also have the smart contracts. If we consider smart contracts as a computer, as a service, you can see that supply chain management, some user scenarios for smart contracts, right? You can think of them as one website, yet the website is not controlled by any individual. It's controlled by like a consortium or by a specific group of folks. So those are so-called smart contracts, right? So my picture is different from other smart contracts. Most of the smart contracts you see today, they are directly, the top blockchain is directly sit on top of the bottom blockchain. But in my picture, we have a network in between. So those are like what Elastos is doing. So what I'm saying is that Elastos has been going on for 17 years. And given that our understanding of a P2P network, of a C++ virtual machine, can we work with NEO or other blockchain companies to do partnership to build the so-called Web 3.0, or some people call it Internet 3.0. So when you hear people mentioning about Internet 3.0, Web 3.0, mostly they are just talks, right? But we're saying that when we do a Web 3.0, we have to have websites. We have to have websites selling used ebooks. We have to have surveillance cameras. We have to have mobile phones. Yeah, another thing is when we see a smartphone, many people don't know that this is a fingerprint reader. The fingerprint reader actually is a single computer, right? So all my fingerprint data is really not on the hard drive of the smartphone, because I'm afraid Apple would be afraid that there's a virus hacked your system and read your fingerprints, and your information got leaked. So your personal information are actually not stored on the hard drive of this phone. It's stored in something called a trust zone, or called a TEE, and which is by ARM, the CPU manufacturer. And actually, the fingerprint reader here is a single computer. It's a Turing-complete single computer. And what I'm saying is that I consider the public blockchain being the trust zone of the internet. Of course, based on what I just mentioned, right? Because people are also saying you own your own data. Can we have our personal data saved on my smart router? So there I give you a little simple example, like a Windows, you have 26 drives potentially, and like a A drive, B drive, C drive. But when you ask, can we replace that single character with a string? So if you can replace that single character with the domain name, actually you can have unlimited number of drives, yet it's still a single computer. There, on this P2P network, everyone could potentially have their own personal drive, and with the applications running on top. And so there's a company, I name just one, actually there are quite a few, doing something called following this vision, right? Doing your own data. And this diagram actually I copied from blockstack.org. Next one. So when we have everybody have their own personal clouds, and we connect all the personal clouds with a P2P network, that's really, we consider that as a platform. And in the past 5 years, as I mentioned, we built a Elastos runtime. See the middle row, which is the C++ virtual machine. That C++ virtual machine I mentioned a little bit, right? What is that? First of all, when it's a virtual machine, it has a runtime or a virtual machine OS. It gives you a new set of APIs or system calls. And on top of the system calls, you can write all the applications. And based on the applications, you're writing a framework. And for the past 5 years, what we did was we took Android 5.0 and we translated every lines of Android 5 Java framework, this is Java code, we translate them all into C++. We're talking about 4 million lines of code. So that's what we have done. The reason why we're doing a C++ framework and C++ virtual machine is that we don't want to let applications to directly touch the metal, directly touch the internet. So yet we give them a programming paradigm exactly like Android. We give them all like libcore classes, libcore methods, all this in C++. And then in the middle, we're building a P2P network. There's really not much new except the IDs would be issued by the blockchain. And of course, the third one, we're building a public chain, collaborating with Bitmain of China. And we're going to do the POW with the mining machines of Bitcoin. And we're going to issue Elastos tokens by December. Next one. And those are the real machines we built for the past 5 years. We have a real phone running. We have a real router running. We have the Banana Pi and running the Elastos C++ runtime. Okay, next one. So this is a little bit of review. When we do development for the C++ virtual machine, actually we support JavaScript, we support Java, we support C, right? And without JNIs, without native call, the programmers does not have to write their own adaptation code from one language to another. It's generated by the operating system. That's where we can quarantine viruses. We can quarantine DDoS attacks. Next slide. Those applications look exactly like Android. If you see our phone, actually we do have a phone in our office. Looks exactly like Android resources. They look very much like Android apps, but none of them works in Java, right? They're either in C++ or in JavaScript. Next slide. And here's the how to write a program. And when you see when we're showing JavaScript code, this is a real code running. And so again, I'm emphasizing that Elastos is really not a blockchain project per se. It is a general purpose mobile application platform. So that's why when you see real applications, they're really real applications. And that's the block diagram of the operating system. And those are the braggings of what is Elastos. And then on the bottom, the reason why we are doing issuing a token, as I said, we share a common vision with Neil. We're building a smart economy together. There we hope the coin we're issuing is really the currency for the GDP of this Web 3.0, right? Let's say if you sell an ebook, from one person to another, we consider that's one transaction. If we add up all the transactions together, that's the GDP of the economy. And if you have a GDP, you need money. And those are the references. I hope people can read at least the first one, right? I really like the first article. The author actually is the same author who wrote the Steve Jobs autobiography. And the guy interviewed the founder of TCPIP, the creator of TCPIP, and interviewed the chief architect of Google, interviewed with people in Apple, and he wrote an article called The Internet is Broken. Starting from scratch, here's how I'd fix it. And I really agree with the article completely, yet we are really, not only we're agreeing it, we are doing it to fix the internet. Okay?